In this video, we're going to talk about Python comprehensions, which are a way to build lists, sets, and dictionaries with significantly less code. So here we have two examples of creating a list from the letters of a word, where we create an empty list and then use a pen to add each letter to that list in a loop. And then the next example, we square each element of a list as we add it to the new list. So both of these, we're creating a list from something that already exists, some type of sequence in this case. So comprehensions are a concise way to create collections such as lists and dictionaries. And the idea is you're replacing the loops we saw just now with a single readable line. Now, you can have these over multiple lines, of course, but maybe it's better to say one statement. In general, comprehensions are more Pythonic and they can be faster than loops, just due to the way Python works under the hood. So there's three types of comprehensions. You can have list comprehensions, which create lists, set comprehensions, which create sets, and dictionary comprehensions that create dictionaries. And you'll notice in each of these, the way we enclose the collection is what differentiates the syntax here. So now let's go to our previous example and let's create some comprehensions. And then we'll go back and talk about how each of these is set up. So the first thing let's do is let's create a list of letters from a word like we did before. So the way we do that is we'll say that's our new list, and it's going to be equal to, and we're going to close this in brackets because it is a list, and we'll say C for C in word. And this is a list comprehension. So if I print let's, and I'll run this code, and you can see here's the old style, here's the new style. I just realized we're not printing this one either, so let's do that, just so we'll be able to compare later. So you can see here's the old style and the new style. We've done that. Now let's create a list of squares of numbers. And in both of these cases, we're using a list comprehension. So to create the list of squares, now we're going to say squares. Now, before, if we just wanted the numbers, we would say X for X in nums. But we don't want X to go in the list. We want actually the square. So we can actually say X times X for X in nums. And we should print squares here too. And so now, when I run this, you can see nothing happens because I didn't save the file. I always seem to do that. You can see that nothing happens because I did the wrong code. Okay, what's going on here? Let's save this. And now you can see that I finally did it correctly. You can see that the list comprehension in just a little bit of code did everything that this code here did. Now we can also create sets and dictionaries. So let's get the even numbers from our numbers. And again, we're going to use braces now because we have a set. And here, X for X in nums will just give us the numbers. And actually, just to show that this is a set, temporarily, let's say 1, 2, 3, 4, 3, 2, 1. So now this is just going to be the numbers in this list. And if I run this, you can see that I printed the wrong thing again. So if I run this now you can see it's a set of the numbers that appear in the original lists. So 1, 2, 3, 4, 3 is already in the set, so it doesn't get added. 2 and 1 also would not get added because they're already there. Now, suppose we wanted to do something where we're putting a condition. So we want to do the nums and we want to do the evens. So we can give it a condition here to say if X modulo 2 is equal to 0, this would mean it's even. And so then it would get added to the set only if it's even, and you can see that that's the case here. So that's a set comprehension that for some reason I like to misspell. What about a dictionary comprehension? So I'll make a table of powers, and we'll say X, and we'll pair that with X to the third power for x in nums. And when I print this, you can see that I get a dictionary with the pairs with each power, and I could also then do a loop. And so you can see that that prints out nicely here. So how did these work? List comprehensions create a new list by applying an expression to each item in the original list. So you see there's this pattern expression for item and iterable. So whatever the expression is, whatever the item is, and again, remember the item would be the members of iterable, the original list. The expression would be something you do with item. So it could just be the value itself like we saw before, or you could do something with it. So as we see in this example where we have numbers, the list comprehension iterates through each x value in nums and then calculates x times x. You could also do 2 plus x and so forth. Then it collects all these results into a new list. We can put conditions on any of the comprehensions, including list comprehensions. So here you see expression for item and iterable, which we had before, if condition. So if that condition holds, then it's going to apply the expression and add that to the new list. If that condition doesn't hold, it's going to continue to the next item in iterable, which is our original list. So you can see here, we are squaring the even numbers in a collection. Now set comprehensions work the same way, except that there's no duplicates. There's also no order. So the pattern here is identical to list comprehensions, except that we use braces instead of brackets. And this ensures that we get no duplicates. So we can create sets of numbers, characters, whatever. And so as you can see in this first example, which is what we just saw, we get 2 and 4 because those are the only even numbers in the list. But then when we look at the words list in the second example, notice we have hello twice. So 2 of the words have H as their first letter. So our first letters set, we're getting index 0 from each word in the list. So H, W, H, P, but since it's a set, H only appears once. Dictionary comprehensions, again, have the same pattern, except that now our expression is a key value pair generated from that item. So in this case, we're doing the cubes, but we're actually pairing the original value x with its cube in the dictionary. So here's a dictionary comprehension. We're taking 2 lists, we zip them together. Zip creates tuples of each pair in the list, and this dictionary comprehension then creates a gradebook where we have the student paired with their grade for every tuple of students and grade in the result of the zip. And of course, this isn't the only way to do this. This is just one example, but as you see when we get this, when we print it, we get a nice gradebook. So use list comprehensions when you need an ordered collection that can have duplicates. If you can't and you don't care about order, use a set comprehension, and then finally use dictionary comprehensions when you need a key value pair or lookup table. It's best to avoid complex comprehensions because they can be unreadable by other programmers, such as your coworkers or potentially your future self. Try to avoid anything that forces the user to have too much cognitive overhead when they're looking at your code. Definitely this is probably on the acceptable end of overly complex, but the goal is just make sure that you try to avoid complexity wherever possible. Use list comprehensions to make your life easier. Don't use them just to show off how much Python syntax you know. And also, keep in mind there are methods such as list, which will create a list out of something, and so you don't always even have to use a list comprehension. Again, it's just another tool in your toolkit, so practice using them and try to understand when the best case is to use them and avoid them, and that comes with experience.